So today we're doing simultaneous equations, and so that's when we have two equations and we want to solve what the unknowns are. So normally we had x and y are our unknowns, and when you have simultaneous, there's two unknowns that you want to solve what it is. So it might end up being like, when we had those questions where so-and-so went to the shop, bought 2 pies, 2 drinks, and then it cost that much, and then someone else did, and things like that. So we're going to do those equations, but using matrices to solve it. And you need to know how to set them up, and because often the questions are show how it is you set it up, and then you have to show how it's solved. So if we have our two equations here, we've got so what I'm talking about is we have these two simultaneous equations, and they both had x and y in them, so we need to solve. So these other numbers or letters here, the A, B, the C and the D, and also this E and the F, they're going to be numbers in this scenario, okay? So it might be like 2, for example. It might be like 2x plus 3y equals 5 or whatever. So when you go to set up the matrices of simultaneous equations, the first matrix up here will be a 2 by 2, okay? And in that will go the elements of, or the numbers in front of the x and the y. So say, for example, A will go there, B will go there, the C number will go there, and D. So you can see going down, this would be the x value, the number in front of the x, and that will be the number in front of the y. Then what you have, you then have timesing by another matrix, which is a 2 by 1. And in there, we pop in the letters that we don't know. So in this example, it's x and y. And then we say it equals, and we will put the two answers to the equations in there, the E and the F. So in that little example that I wrote, a 2 would be there, a 3 would be there, and a 5 would be there, okay? So that's how you set up. So if we just gave them a label, and so what I'm talking about, we just gave those matrices, so we called this 2 by 2 matrix A, we called the 2 by 1 matrix X, and I called this 2 by 1 at the end, I'm calling it matrix E for end, okay? So if you look at it, if we were looking at what we've got there, we would see we've got A times X, so matrix A times matrix X equals E. Now, if you think about it, the matrix A will be filled with numbers, and so will matrix E. So really what we say, we know what that one is, we know what that one is, we don't know what matrix X is. So if I was just solving it like we would normally do in maths, remember how I said you'd bring the A over an equal sign, and because it's timesing on this side, it's going to divide on the other. But we don't divide in matrices. Who remembers what I said the other day? We use the inverse. Good. So you can see over here, this is how we're going to solve it. So we've got matrix A times X, and it equals E. So instead of like this moving over that, instead of dividing, we times by the matrix inverse. Or, sometimes we looked at it as we do the same to both sides. Do you remember that? You divide both sides, yeah? So we're going to times it both sides, whichever way you look at it. So we're going to be using the inverse to solve. Now, it's very important that if the one that, see how the one we don't know, so we don't know this matrix X, because A is in front of it, when you're solving, the inverse needs to be in front of the other one, the E there. So when we solve. So down here is what we'd have to write if they said, show how you solve for that unknown matrix. This is how we're going to do it. So we would take that A matrix, we're going to raise it to the power of -1, and we'll times it by that end matrix EF. So we can type that into our calculators, or essentially they could ask you to show a few things. So they might, so you might want to take note. They might say this is the inverse matrix used to solve the equation. So sometimes they ask what's the matrix used to solve, so you'll have to show them the inverse matrix, just that, okay? And so remember, this is the unknown matrix. We don't know that. All right. We can sometimes have simultaneous equations where there are 3 unknowns. So sometimes we're going to have 3 equations where there are 3 things we don't know. So in this example, it would be the x, y, and z. We don't know them. Okay? And just to show you how you set these ones up, and these numbers the ones in the blue would be all numbers in your equation, and so would these ones in the green. What the equations equal will be there. So when you go to set up a 3 unknown simultaneous equations, you're going to have a 3 by 3 where all the numbers in front of x, y, and z will go down like this. So we will have A, B, C, D, E, F, G, H, and I. They go in there. Now, the X, Y, Z going across there, that will go down that way. So you get, they're your unknowns, and we would know the answer to the equations by putting those numbers in there. So to solve on the calculator, so you only have to ever manually remember do 2 by 2. So this one's bigger than that. So you would be doing this on the calculator. You'd simply type this matrix in. So you write in all the numbers. You would raise it to the power of -1, and then you would times it by this matrix with the J, K, and L. And that will give you, what you end up with is a matrix that looks like this. And whatever the numbers are, or whatever is, that's what X is, that's what Y is, and that's what Z is. So we'll see this in a minute. We're going to do an example. Okay, so here it's said to solve for X and Y. And they're going to ask you to solve using matrices or set it up. Or they might say set up these sets of this equation in matrix form. They're things that they could say. All right, so if you have a look, see how we've got X and Y? They're our unknowns. We don't know what they are. And here I can see numbers in front of them, and here's those n numbers. So what I'm going to go pop into when I set up matrix, I'm going to do the 2 by 2. I'm going to put 5, 2, 7, and 3. Then in here I put X and Y, and then equals 21 and 29. So can you see where I'm getting all those numbers from? Yeah. I'm doing it in the colours so that you can see where it's coming from.
Is that the answer?
What this is just here, what we've got written here, we've written the equations in matrix form, okay? So yeah, so you might get asked to set it up in matrix form, and that will be a couple of marks. So you would do that, okay? Then to solve, if we're asked to solve, what we're going to do is, can you see I've got the calculator here. We've typed in this matrix. We're going to raise it to the power of -1, and then we're going to times it by that one, and it'll give our answer. So what we've just done on our calculator, we've essentially found out what X is and what Y is. So we would say X equals 5 and Y equals -2. So I'll pause it here, and we're going to do this one on our calculator to show you what I mean. We're up to example 6. So now we're going to solve a set of 3 simultaneous equations. So what we're going to do is, there's the 3 equations down here. We've got x, y, and z are our unknowns. Okay, so when we have 3 unknowns, we have to, when we set it up, we'd have a 3 by 3. So I'd have x, y, and z. Then I'd times it by a matrix that has x, y, z there, and then equals the end one. So the numbers that are in front of the letters are going to be our, in this first matrix. So we can see we've got a 3, a 4, and a -2. In the next one, it says 2x, so I put 2, and it says 3y, so I put 3. Now there's no z in that second equation, so if there's no letter, you put a 0. You need to put a 0 there. And then in the last one, it's got x, but we know that's a number 1 in front of it, and 2y plus 3z. And then whatever my equations equal, I pop in this last one. Okay, so if I'm going to go solve this, so I'm going to solve it, what I would be typing in my calculator is I need the inverse of this first matrix. So I need to type this first matrix in, raise it to the power of -1. So remember, this is the inverse matrix, that one there. Okay, and then I times it by this -5, 1, and 3, and I'm going to get an answer. So I'll do it on our calculator, and let's have a look. Okay, so we're putting the answer in here. We found out that the answer on the calculator was -11, 7, and 0. So x equals -11, y equals 7, and z equaled 0. Let's go. A manufacturer makes 2 sorts of orange flavoured chocolates, House Brand and Orange Delights. The number of kilograms of House Brand, so they're calling House Brand X, and the number of kilos of Orange Delights, which are Y, can be made from 80 kilograms of chocolate and 120 kilograms of filling. They can be found by solving the following pairs of simultaneous equations. So you can see here, the question is they want you to solve for x and y, and we can see them in our equation, and they want you to use matrix method. So what you're going to have to do is set it up and then show how you solve it. So here we go. We've got 2 equations. So we'd set up a 2 by 2. So 0.3, 0.5, 0.7, 0.5. I'd times it by they're using x and y, and it equals 80 and 120. Now, if I'm writing how I solve it, I'm just going to write x, y equals, and I'll write this inverse out. Power of -1. And I'm going to let you guys all do that and tell me what the answer is, and we'll come back. Okay, so we do that and we end up with 100 and 100. So what that means is there was 100 kilos, x equals 100 kilograms. Was it kilograms? Yeah. And y equals 100 kilograms. Okay, a worker can assemble 10 bookcases and 4 desks in 36 minutes, and he can then do 8 bookcases and 3 desks in 28 minutes. If each bookcase takes B minutes and each desk takes D minutes, to assemble the matrix BD will be given by. So they're pretty much simultaneous equations that they want you to set up in matrix form. So if you look here, this is 10B, 10 bookcases plus 4 desks equals 360, and 8 bookcases plus 3 deaths equaled 280. So if I go to set that up in matrix form, it would be 10 and 4, 8 and 3 times B and D equals 360 and 280. Okay, now they want you to show which one of these down here of the answers, which one of these setups could you use to solve it. So we need to get our matrices in the solving format. So I would have, if I was solving for B and D, what I would have equals this 10, 4, 8 and 3 to the power of, I'm not going to do that, power of -1 times 360 and 280. So I go and look down there. Is this set up in any of my answers? It's not. So what I think they've done is they've changed this matrix. They've done the inverse first. So if we go and calculate what that is actually on our calculator, what that one is, what does that equal? Let's have a look. Okay, so if I do this on my actual calculator, I get -1.5, 2, 4, and -5. That's what this inverse ends up looking like. And then I would still need to times it with the 360 and the 280. So is this set up anywhere on the page? In the answers? A, good. So there's our answer, A. Okay? Alright, that was a multi-choice. A basketball coach has written 3 linear equations which can be used to predict the points, rebounds and assists that Oscar will have in his next game. The equations are here, written just there. These equations can be written in matrix form, complete the missing thing. So we can see here, we need to, in this one here, we need to fill in the numbers of what are missing. So don't forget that if you have just a letter, it's like a number 1 in front. So it'd be 1, 1, 1. The next one would be 2. This is like a -1. So -1, 3, and 1, 2, and 1. So that would be what's missing. So you can see that's the setup. Now, it says the matrix equation can be solved in the following way. So here, this matrix here is the inverse. It's the inverse of that, isn't it? Yeah? And can you see they're saying fill in the missing, what x they didn't do, they didn't actually write what x was. They want you to find what that number is. So the way I would find that is by finding that inverse in my calculator. So I'll go do that, and you guys do that. Okay, so when I popped in the inverse, so I've popped this into the calculator to the power of -1, and I end up with this matrix, 7, -1, -4, -1, 0, 1, -5, 1, and 3. So what's the answer to x? Good. So we know now that x is -5. And then it says how many rebounds will Oscar have in the next game. So pretty much they're asking what R is. So I just need to go solve it. So I pretty much need to calculate this now with the -5 and get the answer. Okay, so when we solve this, we end up with it equaling 19, 10, and 4. So this would be points, rebounds, and assists. So he gets 10 rebounds.